Okay, so very similar problem. Suppose that a participant in a 30K run-walk event could run at a pace of 10 kilometers per hour and walk at a pace of 6 per hour. Write an equation that relates x and y to the goal of covering 30 kilometers. So 30 is your answer. Okay? We need to write a let statement. Let. X is representing what? I'm going to do x being the first one. Can run, so we're going to do the run. It'd be the running, okay? Hours running. And y be the hours walking. All right, how fast can he run? So 10x, 10 kilometers per hour, plus 6y, 6 kilometers per hour, and the total race is 30. Workforce? Perfect. Now I have to find 3 possible combinations for x and y that will work in this equation. Like I said, start off, make the x 0. So if that's 0, what does y have to be? It has to be 5. Now do the other. If y is 0, then x has to be 3. We'll get a third one as soon as we graph it. Okay? 0, 5. 0, 5 is right here. In other words, number of hours walking. Okay? 5. If they did completely 5 hours of walking, only walking, they're done in 5 hours. And they'll get the 30 in. The combination, if they run, and they have to do 30 kilometers and they're doing 10 kilometers per hour, right? Then it happens that it would be 3. You follow me? Now we put down the ruler, and if we're really neat and precise, you're going to be able to tell the others. There's going to be some in-between numbers in here. We're not hitting a corner right on. So let's kind of guesstimate. Let's say he does, here we got the formula, is 10x plus 6y equals 30. Let's say he makes x 1. I'm going to make x 1, so I want to go to 1. I'm guessing it's close to 3, but it may be a little bigger. So 10 times 1 plus 6y all equals 30. So this is 10, obviously, plus 6y equals 30. I subtract 10. I subtract 10. So I get 6y equals 20. And now I got to divide by 6. Divide by 6, divide by 6. How many 6's are in 20? 3 point something, right? It goes 3 and what? 3 and 2, 6, which is 3 and 1/3. So it is greater than 3, and if we look, if we went over, if x was 1, and I went up, it's 3 1/3. We're right. Okay? Based on one of your ordered pairs, on your ordered pairs, how does it relate to the situation? Well, you could just state, someone could run the whole 30 kilometers so if they're just running, they're running the whole 30 kilometers in 3 hours at the rate of, and the running rate wasn't it 10 kilometers per hour? Okay, that's something you could say. We could do the other way around. Someone could walk the whole thing, and it would take them 5 hours at a rate of 6 kilometers per hour. Got it? See how this is a real world problem? Okay. Number 2. Let's take a look. The Plano Texans are a youth marching band that competes with other groups all over the country. The band director rents instruments to members. Each trumpet rents for $10. So we're talking now, we got trumpets and $10 per month. And each drum rents, so we got drums, and therefore $15. Write an equation that relates the trumpet and drum rentals if the band director charges $115 rental. So again, we start off with let, and we can use the variables. What do we got going here? Trumpets and drums. So we're going to do that. Let T be the number of trumpets. And D be the number of drums. My handwriting is scratchy. It's because my arm is achy. Okay. So, how much are each? Trumpets are $10 each. So, 10 times T plus drums are $5 each. 5 times D. And what's he want? $115. There's your equation. Which of the situations below is accurate? The band director renting out 9 trumpets and 7 drums, or 7 trumpets and 9. Okay, so let's try 9 trumpets and 7 drums. How much would that be? So it would be 9 times 10, right? Plus 7 times 5. Does that make 115? We got to try that out. This is 90 plus 7 times 5 is 35. Last time I looked, 90 and 35 is 125. So this is a no-go. Let's try the other one. 7 drums. 7, oh, sorry, what am I doing? No. It was 9 drums. 9 drums on this one. And 7 trumpets. So the other way around. So 9 drums and 7 trumpets. And so we got, how much are the trumpets were 10. So 7 times 10 plus 9 times 5. This is 70 plus 45, and 70 and 45 makes 115. So that would be the combination that works. So this works. Okay, didn't need a graph, just needed to work it out. Make sense? Important, let me review here, to write down some sort of let statement so you pick out the variable, you know what you're talking about. You don't always have to use X and Y if you like to use a letter that represents the item, such as T for trumpets, D for drums, that kind of thing. You can do that too. It's just 2 variables. Okay? Let's see. We're already at the spiral. Excellent. The cost of a school banquet is $125 plus $20 for each person who attends. This is a classic, typical test question. Okay? So there is a setup fee of $125 and then $20 for each person who attends. So write a function rule to show the cost of the banquet, how it depends on the number of people who attend, which would make sense. If anybody's at a party, you know that's how it goes. Okay, so let's use C for cost, right? Total cost, right? And then we could use the letter P for people, number of people. Kind of common sense. Cost would equal, what are they going to charge me right away in the very beginning? $125. Plus, how much? $20 per person. What is the cost for 70 people? So technically I have to do 20 times 70, but then I got to add on that $125, right? So 20 times 7, 2 times 7 is 14. with 2 zeros plus 125. So if I add that up, the two of them together makes the cost would be $1,525. Common sense. Put it all together. Guys, this is typical questions. You can handle this. Okay? The initial fee would have been $125, and then it would increase by $20 per person. $20 per person. So your slope there is 20. Do you see how it all is tied together? All right, let's take a look at this one. Write a linear function for this graph. What does the slope and the y-intercept represent in this situation? Okay, so now we're looking at a graph, and we're going to try to come up with an equation that belongs to this. Look at the initial value. The initial value, the B is 800. All right, let's see what the story is. Number of guests and the caterer's charge. So the initial value is $800, like a startup fee. We can call it a startup fee, initial value, whatever. How is this increasing? This is interesting. So if at one guest, it went up to, what's that number in between here? $825. So what are they charging per person? $25. So the charge per person is $25. Let's put it in an equation. The cost here is, they're starting with an $800 fee plus $25 per person. Or X on the bottom. Wherever you want, whatever variable, that works. Or you can write it as y equals 800 plus 25x. Or y equals 25x plus 800. Same thing, right? Starting at 800, increasing by 25. There's your slope. Got it? So do you see how you can take a word problem, write an equation, take a graph, write the equation, and now we're going to do a table and write the equation. Write a function rule. We want the equation. We want that slope-intercept kind of thing. Okay? All right, 1, 2, 3, 4, 5. Love it when the x values count as 1. That's my x. This is my y. 9 to 12 to 15 to 18 to 21. Each of them easy, going up by what? Everybody going up by 3, right? So the change in y over the change in x is what? Change in y is 3 per 1. That's your slope. M equals, whoops, that's M equals. Okay? How are we going to find the B? Is there a B? Yes, there is. If we go backwards to 0, so let's make another column. Oh, 0. 0, 1, 2, 3, blah, blah, blah. Then what goes here? Since we were adding 3 to go up, we're going to take 3 away, so this has to be 6. So my B value is 6. Therefore, the equation is y equals, what's it increasing by? 3x plus 6. Make sense? Perfect sense right there. So we were able to come up with a function rule from a table, a function rule from a graph, a function rule from a word problem. If you can do this whole page and you understand this whole page, you can be successful on the 8th grade test. Very, very important. Okay?